Welcome to SDN Tech Networking Podcast, world's first human-curated AI podcast, where we break down complex topics.
We all know that modern AI models, whether you're using Claude or GPT, they have these incredible reasoning capabilities.
Truly incredible. They can analyze, summarize, write some pretty complex code.
But there's this huge persistent problem, right?
Oh, yeah. They are powerful brains, but they're stuck. They're often trapped behind information silos, as the sources put it.
Meaning they're brilliant, but they're blind.
Totally blind. Blind to any live data that happened after their training cut off, and they can't actually do anything in the real world unless you feed them this very static, structured prompt.
Exactly. So if you, as a user, want an AI agent to actually take action, not just spit out text.
Like booking a flight.
Yeah, or managing your calendar or analyzing some internal company data, that fragmentation is a monumental roadblock.
It really is. Every single time a developer tries to connect an AI to an external system right now, they have to invent a whole new custom solution.
It's just not scalable.
No, it's time-consuming, it's brittle, and it makes true large-scale AI integration, well, almost impossible.
And this is the critical problem we're going to solve today. We're doing a deep dive into the Model Context Protocol, or MCP.
Right.
This is a huge initiative to create a universal open standard to connect AI assistants to real-world data and tools securely and seamlessly.
I think the best way to visualize this for you, the learner, is to think of MCP like the USB-C port for AI.
Okay, I like that analogy.
Before USB-C, every single device had its own proprietary cable. Your camera, your phone. It was just a mess of adapters.
It's angle of proprietary connectors, yeah.
Exactly. MCP is meant to standardize that connection point. It's a reliable blueprint for how an AI application, the client, can talk to all these external systems, the servers.
So our mission for this deep dive is to really understand why this standard is so essential for the future of AI agents, get into how its client-server architecture works, and what new capabilities this really unlocks.
Yeah.
Okay, so let's start with the immediate need. I'm building an AI assistant, and let's stick with that travel agent example. I don't just want it to suggest a flight to London. I want it to actually do it. Check my frequent flyer number, compare prices on my loyalty programs, and then actually book the ticket.
Right. Take action.
How do we make that leap from just smart text to a real-world action?
That leap is handled by what we call the AI agent. The agent is this layer of orchestration, the magic thing that sits on top of the core LLM.
Okay.
It manages memory from your past conversations, it figures out which external tools to use, and most importantly, it works with the LLM to make decisions, the strategy, really, to get the task done.
So it's more than just a chatbot. It feels like an evolution of automation.
Yeah.
We used to write these really rigid scripts, like a big Zapier workflow or a Python script.
Exactly, following a fixed logic tree.
Right. And now the agent uses the LLM's brain to make these flexible, dynamic decisions on the fly.
Precisely. It's an automation system that can actually think.
Right.
But you mentioned the fragmentation crisis, and that's where developers are feeling all the pain. How does that smart agent actually talk to the airline's booking system?
Through tools,
Yeah.
right? Which are basically API endpoints.
And that is where the chaos starts.
Because every company designs their API differently.
It's sheer madness if you're trying to build something that works with more than one or two services. I mean, the sources point out this painful reality. One airline might have its search function at API flights, and it needs a specific JSON payload. Another one uses flights list and wants XML and has totally different authentication.
Which means to build that travel agent, a developer has to write custom fragile code, a unique wrapper, for every single airline, every hotel chain.
For everything.
Yeah.
It's exponentially difficult to scale. Imagine trying to do that for 50 different enterprise tools inside a company.
You're writing thousands of lines of code that could break at any moment.
Anytime an API changes, your app breaks. MCP just steps in and says, no more. We're going to standardize the interface between the agent and the tool. We'll provide a standard guide for the AI.
So it replaces that nightmare of custom code. Okay, that really clarifies the urgency here. So if fragmentation is the nightmare, let's get into the blueprint for the dream, the MCP client-server architecture.
It's a classic model. On one side, you have developers building what are called MCP servers.
Okay.
These servers are responsible for exposing a company's data and their APIs, but they have to do it by following the rules of the protocol.
And the consumers of those servers.
Those are the MCP clients. These are the AI applications themselves. Think of things like Claude desktop apps or, and this is really interesting, IDEs and developer tools.
Like who?
We're already seeing big names like Block, Apollo, Replit, Codium, and SourceGraph building on this. This is not just a theory on a white paper, it's being implemented now.
That's a serious list. That kind of early adoption from dev tools tells me this is becoming foundational pretty quickly. So what's the technical glue that holds the client and server together?
The protocol is really specific here. It mandates that the communication format has to be JSON RPC.
JSON RPC, remote procedure call.
Yeah, it's a simple, stateless protocol. It just defines how a client can call a function on a remote server and get a response back.
Hold on, though. JSON RPC it feels like a protocol from the early 2000s. It's light, sure, but it's stateless. Is that really enough for these complex, multi-step agent tasks? What are the limitations there?
That's a great question, a really sharp one. And yes, we accept its stateless nature because MCP is designed to be an interface layer, not a session management layer.
Okay, so it's not trying to do everything.
Exactly. Its brilliance is its simplicity. It's perfect for this kind of machine-to-machine call because it avoids all the complexity of, say, gRPC or GraphQL when all you really need is a quick function call.
So the state, the context, all of that is managed somewhere else.
It's managed by the agent on the client side, and it's reinforced by what the server provides, which we can get into. The complexity is delegated away from the communication itself.
Understood. And how does that data physically travel?
Two ways. The first is what you'd expect, HTTP for network connections. But the second is really telling for developer environments, standard I/O.
Standard I/O, so just simple input and output streams.
Exactly. The spec actually calls it out as the simplest and fastest way for two local processes to talk. So if you have your IDE running on your laptop,
Right.
and a local MCP server instance running alongside it, standard I/O lets them communicate instantly. No network overhead, no firewalls to worry about. It's built for speed and local utility.
Okay, let's give it to the server itself. For this to work, the MCP spec has to be really clear about what the server shows the AI client. I understand it's structured around 3 essential pillars.
That's right. Pillar 1 is tools. These are the actions the agent can perform, the server's capabilities.
And they have to be described in a standard way.
They do. It must include a human-readable description and, this is key, a clear input and output schema.
So this is that standard wrapper we talked about. Instead of API flights, the client just sees a nice, clean search for flights tool with the parameters it needs.
Precisely. Pillar 2 is resources. This is the static data, the documents the AI needs to make a good decision.
So things the LLM wasn't trained on. Current information.
Yes, and again, it has to follow a defined structure, a URI, a title, a description. The URI can point to a website, a local file, even a Git repo.
So examples would be things like, what, refund policies?
Refund policies, city guides for visa rules, internal compliance docs, a live list of airport codes, all the context that grounds the LLM in reality and helps it make a compliant, accurate decision.
Which is vital for avoiding hallucinations.
Yeah.
Okay, now pillar 3 is the one I find most clever. Prompts. Why on earth would the server provide the prompt?
This is a huge design choice, and it's all about reliability. Pillar 3 says the server developer, the person who built the tool, has to provide predefined, optimized instructions for the LLM.
So instead of the client application guessing how to talk to the tool.
Exactly. Why guess? The server developer knows their system best. They know the security rules, the data formats, the most efficient way to call their API.
So they just provide the perfect prompt.
Yeah, they provide the prompt, something like, you are a customer service agent. Use the check refund policy tool and make sure all dates are formatted as YYYYMMDD to avoid an error. It prevents so many problems.
That's really smart. It outsources the prompt engineering back to the expert.
It does. Now, while the server is exposing all this power and guidance, the client, the app on your machine, keeps critical control over security and the LLM itself. There are 3 key features for this.
This balance of power is so important for trust. Let's start with security, the concept of roots.
So roots define the sandbox. They're just folders on the client machine that you, the user, explicitly say the MCP server is allowed to see or interact with.
So if I'm using an AI agent in my code editor.
Right. You might grant it access to your project asterisk folder, but that's it. It can't go snooping around your entire hard drive or access sensitive config files.
That is non-negotiable for any kind of enterprise use.
Yeah.
Total separation of access.
Absolutely. The next feature is sampling. Sometimes the server itself might need a little bit of LLM reasoning, maybe to summarize a huge document it has in its resources.
But you don't want the server to have to run its own LLM. That would be heavy and expensive.
It would defeat the purpose. So the server sends a sampling message to the client. The client, who already has the LLM connection, handles the actual call to the model.
So the client controls model choice, token limits, and the cost.
And the cost. The client pays for the inference, and the server stays lightweight. It's a really smart delegation of work and responsibility.
Which also has privacy benefits, since your data stays within your security perimeter.
Okay.
And the third one,
Elicitation. This is the human-in-the-loop part. The server might get to a point where it needs more information from the actual user.
like a confirmation before booking that non-refundable flight.
Exactly. Or clarifying an ambiguous request. So the server sends an elicitation message to the client.
And the client is responsible for showing that to me, the user.
Right. The client handles the UI, gets the response from you, and then relays it back to the server so the job can continue.
That sounds necessary, but I have to ask, does that back and forth create a clunky user experience or add a lot of latency? The server is basically telling the client what UI to show.
That is the central design challenge, yes. The success of it really depends on how well the client implements that part. A good client will render a rich, fast UI component to get that information efficiently, not just show you some raw text. The standard just provides the mechanism. The UX quality is up to the client builder.
That makes sense. Okay, so we've covered the why and the how. Let's zoom out to the so what. With this fragmentation barrier gone, what are the really high-impact uses we're seeing?
The jump in capability is huge, especially when you mix context and action with sensitive data. Agents are becoming real personal assistants, securely accessing your Google Calendar or Notion through that root security model.
And in the developer world, this is just transformative.
Oh, absolutely. The aha moment for a lot of developers is seeing an agent go way beyond just writing a code snippet. With MCP, tools like Claude Code can generate an entire web application just from a Figma design.
Wait, how does it work through this protocol?
Well, think about it. The Figma design is provided as a resource. That's the context. The IDE's own commands, like creating a file or installing a library, are exposed as tools.
I see.
And the prompt is pre-optimized by the IDE developer to make sure the LLM generates secure, structured code. The agent can see the visual design and then use the tools to build it with way fewer mistakes.
That's moving the AI from just a pair programmer to more of a project executor.
And in the enterprise, it's solving these huge data silo problems. We're seeing chatbots connect to multiple databases at once, Snowflake, BigQuery, you name it, through these standard MCP servers.
So that an executive can just ask a question.
Yeah, they can ask something complex like, why were our sales down in North America last quarter? And the agent can securely query all three systems and give a single synthesized answer. It's incredibly powerful.
I also think the open, collaborative nature of this whole thing is really important.
It is. The sources mention organizations like Block who see open tech like MCP as the bridges that connect AI to real-world applications. It's a push for this to be a public good, not a proprietary lock-in.
Yeah, and Anthropic is actively encouraging developers to contribute connectors to the open source repos.
It's a collective effort, for sure.
So to wrap this all up for you, the learner, the Model Context Protocol is providing that essential context and connectivity that these powerful LLMs were missing.
It standardizes the interface and, maybe most importantly, it simplifies development because you're just building against one protocol.
And it moves AI beyond just generating text into secure, contextual, action-oriented agency.
We're really watching AI transition from being a fantastic reasoning engine to being a reliable executor of complex tasks inside the systems we already use. It just raises the bar for what every AI application can do.
All right, here's the final thought for you to chew on. If MCP really does become the USB-C port for AI, this universal connector that lets any agent securely talk to any system, what is the next standardized layer we're going to need?
Ooh, interesting.
Once every AI agent can talk to every system, how do we standardize how they talk to, cooperate with, and resolve conflicts with each other? That intersection of universally connected autonomous agents, that's where the next monumental challenge is going to be.